Okay, so I feel better about being able to measure this grade now in the on my commute. I think it's always pretty funny. 2%. I know we've looked at a number of different grades now, and you're going to look at more in the optional quiz you do in a couple minutes. But I always think it's fun to think about, how steep certain parts of my commute are. Like this is the last little crank up to campus. This is the very top of Archie Briggs, pretty steep. This is coming out of the river on Archie Briggs, which is also very steep. Those are way steeper than 2%. But the rest of the commute, quite a bit of it is flat for a long period of time, and some of it's even downhill, like right here, right here, right here, and this is dropping on Mount Washington, dropping down, and then climbing back up. So there are a whole lot of sections of this commute that are not super gnarly, super burly, super quad intensive. The parts you remember are the hard parts, but the parts you don't uh, contribute to the overall average of only 2%. And that's kind of one of my favorite parts of this lesson, is understanding the difference between an outlier, which would be these little tiny localized super steep sections that we talk about, and the more kind of normal occurrences that don't really warrant too much discussion. And there's a lesson in that. We're going to come back to that as we go through the course. Okay, so real quick, when we're talking about looking at an app like Strava or an elevation map in general, we're going to look at another one here that wasn't generated by Strava but is publicly available online. Back to my little picture of me climbing up a mountain, which I've never actually ridden my bike up anything even close to this steep. This is approaching 100%. There's no way this guy would even be able to be standing on that bike on that hill. If you actually think about that distance and that distance, they're almost the same. So that's 100% grade almost. Yeah, your legs you'd fall right over. It would be terrifying to ride down, and it would be impossible to ride up. But I didn't come here to tell you that. I came here to talk about the sections that tracking apps actually track. So when you look at the vertical axis, so back here again, I'll back up one. The vertical axis here correlates to your rise. That correlates to your rise. The horizontal axis, somewhat confusingly, but now hopefully understandably, correlates to the road. Okay, they don't put it on a diagonal, but they do measure it on this horizontal. So this is the rise, and this is the road, and there's how that relates to your grade triangle. The run doesn't get measured. It isn't measured because you don't really experience it. You experience the rise, that's the change in elevation, and you experience the distance, that's the road, but you don't really experience the run. I mean, the run is there. It's there as the whatever the second dimension of the triangle, besides the rise, but you don't really experience it unless you're on perfectly flat ground the entire time. So just so you know, that's why we have to kind of either A, do Pythagoras, which I know some of you are probably still going to want to do, or B, use the grade calculator or some other tool to do the math for you. Okay, let's do one more example. Here are some wonderful little shots taken from a very, very special place in Oregon. You got Sahalee Falls and the Blue Pool and the wonderful, wonderful Mackenzie River and the trail that runs right next to it. It's a beautiful, beautiful place to fish. It's a beautiful place to ride a bike or go for a trail run. Super, super, super rad. So I want to look. I did a quick little Google search, Mackenzie River Trail elevation, and I got this. The trail begins at an elevation of 3,200 feet. Oh, they put feet twice there. That's kind of cute. 3,200 feet, 2 miles above Clear Lake, and ends at an elevation of 1,450 feet and meanders along the banks of the Mackenzie River, blah, 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 blah. Okay, so here, this is an elevation map of the Mackenzie River. One thing I like about this one an awful lot is it starts down here at 0, which is not super important because these are in feet and these are in miles. But nonetheless, I'm gonna mention that now, put that bug in the back of your mind, and then we'll come back to it later. So looking at this elevation map, here's Clear Lake up here, and you start riding. And this is actually, I believe it's this whole first section is the most technically challenging if you're mountain biking it. It's super rocky, a lot of lava. I think I've been trying to ride this trail for 15 years and still haven't gotten through it without falling off my bike at least once. So you start up here and up, down, slight little changes, and then you get a very nice descent. And then descend again, and you get to climb right here. We're going to come back to that in a second. And then drop, and then it's this last part here through the old growth is absolutely stunning. Just huge trees. The whole place just smells wonderfully mossy and kind of like mulch. It's a wonderful, if you've never experienced the Mackenzie River Trail, I definitely do it as soon as we can get back to these wonderful places again. Okay, so let's calculate the average grade of the Mackenzie River Trail. Now, it's going to be negative because it's going downhill, but that's assuming you go downhill. You can also go uphill and it will be positive. Okay, so let's figure it out. We know that it starts according to this, and we can kind of see this on the elevation chart too. That appears to be about 3,200 feet. That sure does right there, 3,200 feet. And then it says it drops at an elevation to 1,450 feet. I'm not, you know what? It could be 1,450. This is a 500-foot elevation difference here. And this comes in just under 1,500, it looks like. So you know what? I believe both of these. 3,200 to 1,450. So what I'm going to do is I'm going to kick out of the PowerPoint here for a second and go back to the grade calculator. Okay. So what I'm going to do is I'm going to delete the road. And I'm going to show you something cool about Excel. Where it says rise, what we actually have to do is we have to subtract 3,200 feet minus 1,450 feet. We have to subtract these two numbers to get that rise. Something you can do in Excel, which is pretty cool, is you can make Excel do the subtraction for you. So you can put the formula in equals 3,200 minus 1,450. Now, the things to note about this is make sure you put that equal sign. Otherwise, it's not going to know what you mean. It's going to think it's text. And then when you press enter, it's going to tell you that that's a 1,750 foot drop or climb, depending on which way you're going. So that's the rise of the Mackenzie River Trail. Okay, so I wanted to show you that cool little formula use. All right, let's go back to the PowerPoint here. I want to re-engage it here for a second, because we have to now figure out how long this trail is. And I'm going to look down here at the scale. These are in miles. Okay, so this is a little confusing, but I think I understand what's going on. This 2 goes with that slash right there. It's confusing as heck how they put it right in the middle of these 2. But assuming this starts at 0, that would make sense that this is 1, 2, 3, 4. It doesn't make sense that this would start at 1. You would start at 0 because you start at the beginning of the trail and you haven't gone anywhere. So 0, 1, 2, 3, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 and some change. 24 and some change. What do you want to call that? I want to call that 24. Each of these is a mile. That looks to be about 1/4 of a mile. So I'm going to call that 24.25 miles. Now, you already know what's going to happen if I try to put 24.25 in for the road. Now, first of all, I'm putting it in for the road because it is the road. It's not the run. We don't ever get to measure the run. The run is kind of invisible to us. It is definitely the road, but the big problem is that that's in miles. So I'm going to convert that to miles right here in Excel like I did at the board before. I'm going to go equals 24.25 miles times 5,280 feet in a mile. And that, my friends, is how many feet the Mackenzie River Trail is. If you start at Clear Lake and go all the way down to, I think it's Paradise is the bottom, I think, if I remember correctly. About 1/8 of a million feet, which is actually pretty rad. When you look at that number compared to this number, you're like, holy God, like this is just about one. Well, there you go. It's just about 1%. It's just about 1%. As a matter of fact, it's less than 1%. Let's give ourselves some more. Oops, I was totally wrong. It's more. 1% would be 1,280. My apologies. There. And look how close the right and wrong ways are. I mean, they're agreeing with each other out to 6. Oh, there we go. They had to go out to 4 decimal places until they disagreed with each other. because the run is going to be so close to the road over this little tiny rise and this huge distance. So just about a 1.4% grade. It rounds to the nearest whole number of 1. You can round to whatever you want to round it to. It's totally fine. So it's a very, very, now, I was going to say it's a very, very, very mild grade. I need to add another word to that, though. It's a very, very, very mild average grade. Because if you start here and connect it to the end here with a straight line, it is definitely a very, very, I'll do that so we can visualize it. It is an extraordinarily not crazily steep. You can't really see that, can you? Let's make it a little bit bigger so we can see it. There. But then there are some sections of it that deviate quite far from that average grade. And I want to talk about one in particular. I call this Jen's Hill. My wife's name is Jen, and I call this hill right here Jen's Hill. She hates this climb. She actually will very often complain about the Mackenzie River Trail and say, I'm not doing that because it's uphill, even if we're going downhill. But if you're going downhill on the Mackenzie River Trail, you do have to confront this little section right here. I'm going to recalculate just the grade of this little section right here. And we're going to see what that number is. It looks pretty steep, but then again, it's a little misleading because these scales are not the same unit. This is feet and this is miles. That's steeper than it looks. I mean, that looks, if we were to zoom in on it, let's zoom in on that really close. Whoops. Let's go to 400. Yeah. If you look at that right there and look at this right here. Oh, my goodness. That's that guy I told you would never ride up the impossible 100% grade. They look very similar. They're tilted at about the same angle. So that little bit right there, if we zoom in on it again, I'm sorry about all this crazy, I don't know why it's bouncing all over the place. That looks to be about 100%. Now, I know it's not 100% grade, but I think we can pull some numbers off of it to figure out what it actually is. So what I'm going to do is I'm going to scooch over a little bit. Okay, so if I drop this down and drop this down, what is that? I'm going to add some lines with your permission. I'm going to add some lines to help me figure this out. So that looks to be about the distance. I know I'm going horizontally. I'm going to make that shape bigger. That looks to be about the distance from the trough to the crest. And if I drag that down here, that's not even a full mile. That looks to be about 2/3 of a mile. So that hill is about 2/3 of a mile. So what I'm going to do is I'm going to come over to my Excel grade calculator. And that's the road. Remember, 2/3 of a mile on the trail is the road. And I'm going to take 0.667, which is 2/3, times 5,280 feet. Okay, so that has about 3,500 feet of climbing to do. But now this rise is nowhere near correct. This is the overall rise of the trail. I need to look at just that one section right there. So I'm going to help with my little ruler here. I'm going to turn it 90 degrees. And I'm going to put the top at the top and the bottom. You know, it's pretty close, actually. It's pretty much right where it needs to be, I think. Yeah, there we go. That looks to be about right. And I'm going to take this over to this scale and see what that is. And that looks, I don't know if you're seeing the same thing I'm seeing. That looks to be about halfway between this one and that one. And since this is a 500-foot change, that must be about halfway or about 250 feet. So I'm going to come back here and I'm going to put 250 feet in there. And that tells us that the grade of that hill is 7.1%. Definitely steep, but nowhere near some of the grades that I pull on my daily commutes. Now, what makes it harder is it's on a mountain bike. That does, things get looser, things get a little bit more tricky because they got rocks and stuff in it. And 7.1% is definitely significantly steeper than the overall trail, which we saw back here. Let's re-engage this and turn this back to this. But as steep as that looks on the map, it actually only ends up being 7.1% in reality. Okay, so I hope all this helped. If you want, have at the quiz. I'm also going to put another video after this one in case anybody is interested in seeing a neat justification as to why the Pythagorean theorem works. Not at all necessary. You can stop right now and try the quiz. We'll see you soon.